biologists. I am Justin and now running late. By the way, we have a reporting today about 5 functional groups. Come on, join us! Hola, I'm Princess, and for today, we are going to tackle 5 different functional groups. And first on the list is the aldehyde.
When a carbonyl group, the central carbon in the group is attached to a carbon group and a hydrogen, we are dealing with the organic compound aldehydes. To name an aldehyde, just take the standard name for the carbon chain and change the suffix "e" to "al". There is no need to use a number to identify the carbonyl group of an aldehyde because it can only be at the end of the parent chain, so it must be a carbon one. Now, let us name an aldehyde structure. 1. Find the longest carbon chain in the structure. We have a total of 7 carbons, which means our longest carbon chain is heptane. Next, change the suffix "e" to "al", so the structure have the IUPAC name heptanal. Aside from naming an aldehyde, let us now try to draw the structure of an octanol. 1. Identify the longest carbon chain by looking at the prefix of the IUPAC name given. The prefix is oct, so we are going to draw 8 carbon atoms. Next, add the functional group aldehyde at the first carbon. And here we have the structure octanol. Aldehydes are found in flowering compounds such as benzaldehyde, which gives fresh aroma and flavor of almond, cinnamaldehyde or cinnamon oil, and vanillin, the major flavoring component in vanilla beans.
The second functional group that we are going to tackle is about ketone.
The organic compound ketone is a functional group with a structure of carbonyl group attached to 2 alkyl groups. The organic compound ketones are named by following the rules for standard IUPAC naming and adding the suffix "-o". Now, let us name a ketone structure. First, find the parent chain with the carbonyl group. Second, change the suffix of the parent chain to "-o". Third, number the parent chain to give the carbonyl group the smaller number, and since the carbonyl group is in carbon 2,
The name of structure
will be 2-pentanone. If there's 2 carbonyl group in the structure, identify the parent chain, the location of the carbonyl groups, and add the di to the suffix "-one" because we have 2 carbonyl group present. So, we name it the structure 2,5-hexane dione. Now, let us try to draw ketone structure. We have here the given IUPAC name 3-hexanone. First, identify the parent chain. Since the parent chain in the given name is hex, it means that we are going to draw 6 carbon atom structure. Next, number the carbon and draw the carbonyl group on the location given. And this will be the structure for 3-hexanone. Ketones are most commonly utilized as solvent in the explosives, lacquers, paints, and textiles. Tanning, preservatives, and hydraulic fluids all contain ketone compounds.
The third functional group to be tackled is about carboxylic acid.
An organic acid with a carboxyl group bonded to an R group is known as carboxylic acid. It has a general formula of RCOOH or RCO2H, with R group referring to the alkyl, alkenyl, or other group. In naming a carboxylic acid, we follow the rules for standard IUPAC naming and add the suffix "-oic followed by a word acid, and the parent chain is numbered starting with the carbon of the carbonyl group. Now, let's try to name a carboxylic acid structure. First, identify the parent chain. Number the parent chain starting with the carbon of the carboxylic group. The parent chain has 6 carbon atoms, which is associated with the name hexane, but instead of naming it hexane, the suffix "-e" will be replaced with "-oic followed by the word acid. So, we are going to name it as hexanoic acid. Now, let's try to draw a structure of the given name, propanoic acid. The oic acid in the given name tells us that it is a carboxylic acid. The first thing to do is to draw deoxy-OOH at the end of the structure. Then, we are going to work out with the parent chain. The prefix "prop" tells us that there are 3 carbons in the longest carbon chain. The "an" at the middle of the name here means that this is an alkane, so we are going to draw a propane structure. And this is the structure for propanoic acid. Carboxylic acid can be abundantly found in nature. Hydroxyl acids, such as lactic acid and citric acid, as well as a variety of keto acids, are key metabolic providers found in almost all living cells. Amino acids, which also have carboxyl groups, make up proteins.
The second to the last functional group that we are going to tackle is amine.
Amides are carboxylic acid derivatives in which the single bond OH group from the carboxyl is substituted with the group NH2 and consist of an alkyl group attached to a nitrogen atom. Amides are named as carboxylic acid derivatives. The suffix amide replaces with the "ic" ending of the common name or the ion ending of the IUPAC name of the carboxylic acid. Now, let's name an amide structure. Identify the parent chain in the structure. We have a total 3 carbon, which is associated with propane, but in naming amide, we will change the E ending and add with suffix amide. So, we name the structure propanamide. Now, let us draw the structure of the pentanamide. The suffix amide here represents that the structure that we are going to draw consists of alkyl group attached to a nitrogen. First, we are going to draw the CONH2 at the end part of the structure.
Next, we are going to identify the parent chain. In the name given, we have the prefix pent, which means our parent chain is consist of 5 carbon atoms. And here we have the structure of pentanamide.
Acetamide or ethanamide and dimethylformamide, which is used as solvent, sulfur drugs, and nylons, are among the commercially important amides.
The last functional group to be tackled today is esters.
Esters are derivatives of carboxylic acids with COOH group attached. The hydrogen in the carboxylic acid is replaced by a hydrocarbon group in an ester. This could be an alkyl group like methyl or ethyl, or a benzene ring containing group like penyl or benzyl. In the nomenclature of esters, the alkyl chain from the alcohol is referred to as the substituent and change its suffix to YL or il. This alkyl chain has given no number. The name of the parent chain of an ester is taken from the carboxylic acid, and the suffix "-ate" is used instead of the E ending. Now, let's try to name an ester. First, identify the alkyl group in the given structure that came from alcohol which is directly connected to an alcohol and change its suffix to YL or il. In the structure, the group attached to an alcohol is methane, so our substituent will be methyl. Then, name the part that came from carboxylic acid and change its suffix to "-ate". So, our parent chain, which came from carboxylic acid, is ethane. But we have to change its suffix to "-ate. So, the name of the structure will be methyl ethanoate. Now, let us try to draw the structure for ethyl propanoate. The 8 here tells us that we have a functional group COO. Now, let us work on the parent chain. The parent chain is from carboxylic acid, so the prop here means there are 3 carbons in the parent chain. The ethyl here, which is attached to an alcohol, is our substituent. So, we have here the structure, ethyl propanoate. In the production of dyes and pharmaceuticals, sulfuric and sulfurous acids, esters are utilized. Sulfuric acid smooths well-known esters. Dimethyl sulfate is a poisonous compound.